Hello and welcome to Taboretum channel. Today we'll be talking about a coffee cup and a sleeve. This is a coffee cup that I got, and the problem is it gets really hot when you use it. So let's boil some water because I don't want to waste coffee, and let's pour into the pour cup 400 milliliters of 95 degrees water. A disclaimer: no harm was done to any coffee during this whole experiment. And a cap on top. Plus now a grill thermometer so we can check how fast water cools down. After 10 minutes, temperature of water dropped to 78 degrees Celsius. As you can see here, the cup gets really hot. It actually gets so hot that it's barely doable to hold it, making it not usable at all. The solution was simple. I needed a 3D printed cup sleeve, long sleeve actually. I have designed my sleeve using a previous project, and it was actually a pot, and I just changed the parameters of the cone, the size of the cone. If we have a quick glance here, we start with the cone, then we create a small sketch down here, you can see it at the bottom, and we create an additive helix out of this sketch, like that, with the proper settings, and then we repeat the pattern around, and that's basically it. If you are curious, the only fancy part is actually here, that the pitch of these helix is 10 times the height of the cone. The height of the helix is equal to the height of the cone, and the cone angle, it's pretty complex, right? Because it's arcus tangens of the difference between the radiuses plus 3 millimeters, because this is the width of this rib divided by the cone height, right? So we can calculate the arcus tangens 5 degrees, but these are gory details. And that's basically it. That's our shape. And now we'll go to the PrusaSlicer and we'll slice it. Now we are in PrusaSlicer, and as usual I will use my very favorite spiral mode, Vase mode. And the only thing I will change from my default setting, I will remove the bottom part, because otherwise it won't be a sleeve, right? It's actually a long sleeve even. Let's slice it. And yeah, as you can see, there's no bottom, and it will be a nice sleeve for our cap. And now the actual print, printed out of PLA. I hoped that it will be heat resistant enough. If not, then I can use my heat resistant PLA filament. So here it is, nice and shiny, white and shiny long sleeve for my coffee cup. And let's assemble the thing. So here's the cup. Ta-da! It fits nicely and looks nicely. And now let's do some real test. Again, right? So the same temperature, same amount of water. So 400 milliliters, 95 degrees Celsius, and we'll use the same measurements. It is, yeah, I know it's boring because it's my gooseneck kettle that I use for my coffee brewing. So the idea is that you pour slowly. Yeah, but it's finished now. And let's measure it. Actually, it finally rose to around, as you can see, the temperature reached around 68-ish, close to 70 degrees Celsius. And this is a temperature that you can actually hold, so that that proves the point and the thing works. The drop of the temperature over time was almost the same, so it dropped to 79 degrees after 10 minutes. So it's because the majority of the cooling happens on the surface, so it was not a huge difference. But from the usage perspective, from the how you can hold it, it is a huge difference. And honestly, I think it looks pretty cool. So I enjoyed the process and I'm pretty happy with the results. So thanks a lot and happy printing. Share your thoughts, subscribe and comment. Thank you. Take care. Bye bye.